Welcome to the Explainer. Today, we're tearing down a massive PERN stack tutorial to look at the exact architecture you need to build a modern, full-stack grocery delivery app totally from scratch. Let's get right into it.
Think about the sheer engineering complexity happening behind the scenes the second you hit checkout. We've all gotten so used to our groceries just magically appearing at our doorsteps instantaneously, right? But the software routing a single apple from a digital cart to a physical delivery involves an incredible amount of coordination. We're talking active inventory locks so two people don't fight over the last carton of milk, securing payment gateways, and firing off real-time webhooks. So today, we're popping the hood to see exactly how all that magic is programmed and orchestrated.
And the biggest thing to realize right off the bat is that to make a modern delivery app actually work, you aren't just building one interface. You're wiring together three distinct dashboards: user, admin, and delivery partner. You're essentially building three totally separate applications that all have to talk to the exact same database in real time. And the major engineering hurdle here? Avoiding race conditions and data collisions. When a user submits an order, an admin confirms it, and a driver accepts it, often within literally seconds of each other, your database needs strict transaction management and concurrency controls. Otherwise, data gets overwritten. You have to ensure all three clients reflect the exact same truth.
To break this down, here's our architectural blueprint for today. We'll be covering the app ecosystem, the PERN tech stack, building the user journey, admins and delivery partners, and finally, global state and tracking.
Okay, Section 1, the app ecosystem. Let's look at the macro-level engineering.
So your user interface has to provide this ultra-seamless shopping experience, while the admin dashboard acts as the complex inventory and logistics backbone. From an engineering standpoint, these two environments need entirely different security architectures. The user-facing API routes have to be hyper-optimized for speed and caching to handle sudden traffic spikes. You want friction to be as low as possible so customers can quickly filter products and load up their carts. But conversely, the admin dashboard needs strict role-based access control. Its API routes are protected by robust JWT middleware, making absolutely sure that only authorized store managers can actually mutate inventory data, run CRUD operations on massive product catalogs, or manually assign high-value orders to specific delivery partners.
Moving on to Section 2, the PERN tech stack. Let's look at our foundational materials. This source material lays out a seriously scalable approach for a modern app. PostgreSQL handles the heavy data lifting, and it's heavily augmented by Neon's serverless architecture. Neon is brilliant here, honestly, because it gives you connection pooling right out of the box and lets developers instantly branch their database for testing new features without ever touching production data. Then on the back end, Node and Express run the server routes nice and efficiently. And for the front end, migrating from older toolchains to Vite combined with TypeScript is pretty much the gold standard right now. Vite gives us that near-instant hot module replacement during development, while TypeScript enforces strict typing across our complex order payloads, which drastically cuts down runtime errors before they ever even get close to the user.
To push that front end to production readiness, we wire in some absolutely essential supporting libraries. Tailwind CSS is in there, not just for rapid styling, but to keep the final CSS bundle size incredibly small, which is crucial for mobile users shopping on, say, spotty cellular networks. Then we have React Router DOM for securely managing route guarding that redirects unauthenticated users away from checkout pages and completely blocks unauthorized access to the admin panels. Lucid React brings in a lightweight, consistent SVG icon set, and React Hot Toast handles our asynchronous UI feedback, dropping those slick, non-blocking notifications the exact millisecond a backend promise resolves.
All right, Section 3, building the user journey and the customer experience.
The user journey essentially has to flawlessly bridge the gap between "I'm hungry" and "your delivery is 2 blocks away." It acts as a highly optimized funnel. Now, moving a user from authentication to browsing flash deals is pretty straightforward, but the real complexity hits during checkout. This tutorial implements a Stripe payment integration, which means handling some serious asynchronous logic. The front end requests a payment intent from the Node backend, which securely talks to Stripe. But crucially, the app has to listen for Stripe webhooks, those server-to-server HTTP callbacks, to definitively confirm the payment actually succeeded before it generates the order in the database. This webhook implementation, paired with idempotent requests, makes absolutely sure users are never double-charged, even if their connection drops out midway through checkout.
And when you're building at scale, organizing your React front-end by separating reusable UI components from dedicated page views becomes an absolute necessity to manage technical debt. By leading into atomic design principles, we prevent that notorious issue of prop drilling. If we keep full-screen views isolated in the Pages directory and highly reusable stateless bits like buttons and product cards in the Components directory, the team can scale the interface predictably. Plus, isolating global logic in a context folder ensures that your business logic doesn't get tangled up in presentational code. That minimizes unnecessary re-renders across the DOM whenever a user interacts with the app.
Let's hit Section 4, Admins and Partners, focusing on the operational workflows.
This sequence right here operates exactly like a finite state machine. To maintain absolute data integrity, the PostgreSQL database uses strict enum arrays for these exact statuses. This completely prevents invalid transitions on the back end. For example, a driver literally cannot update an order to delivered if it was never marked out for delivery in the first place. When an order is placed, the admin confirms and assigns it. Then the driver, using their own specialized dashboard, triggers the subsequent status updates. Those updates patch the database and instantly reflect on the user's screen. And the whole cycle securely terminates when the driver inputs a one-time password provided by the customer, mathematically proving the physical handoff actually occurred. Pretty cool, right?
Finally, Section 5, Global State and Real-Time Tracking.
So the Context API handles the specific global data payload needed to keep the application responsive. Instead of making redundant, heavy database queries every single time a user switches pages to check what's in their cart, the master record is just stored globally right in the browser's memory. And this is where some advanced React techniques come into play. By using hooks like useMemo, the app automatically calculates derived states, like the dynamically shifting subtotal, complex tax logic, and variable delivery fees, completely on the fly. This optimizes React's reconciliation process, basically guaranteeing that the floating cart icon and the final checkout invoice are always perfectly synchronized.
But integrating Leaflet is what truly transforms the delivery experience. The engineering behind it, though, relies on constant data streams. The application bridges the physical and digital worlds by establishing a real-time connection. It usually utilizes WebSockets like socket.io rather than relying on clunky, resource-heavy interval pulling. So the driver's mobile device broadcasts live GPS coordinates through a dedicated WebSocket channel. The user's front end is subscribed to that exact channel, actively listening for payload events. Every single time a new coordinate drops, the Leaflet map component naturally reacts to the state change, smoothly animating the delivery vehicle right across the map layer.
So the next time you track a delivery driver on your phone, you're going to know exactly how the context APIs, database enums, and routing libraries are firing off behind the scenes to make it happen. Now that you understand the blueprint of this PERN stack masterpiece, what massive, complex system are you going to reverse engineer next? Thanks for joining me on this explainer, and keep building.